In this video, we're going to be talking about absolute value functions. Today, we're going to apply the distance definition to absolute value equations and inequalities. It's really kind of an interesting definition of what an absolute value is. I think that there's a kind of like functional understanding of what an absolute value is, which I think that folks have misinterpreted to be a definition. And so we're going to talk about the actual definition, which I think is more intuitive. Then we're going to solve absolute value equations and inequalities. And then we're going to use absolute value equations to analyze absolute value functions. So let's define absolute value. A number lives 6 units away from the number 7. What are these values? Pause the video and think of them on your own. Okay, so let's first kind of use mathematical machinery to put this together. So a number lives 6 units away from the number 7. So a number, we always denote that as x, and we live 6 units away from the number 7. So living 6 units away, this means we're talking about a distance, right? This means we're going to be using absolute value. So if I rewrote this thing using mathematical notation, without using words, that's exactly how I would say this. The absolute value of x minus 7 is equal to 6. A number lives 6 units away from the number 7. The number 7 is denoted as x minus 7. A number is x. And when we say a number lives 6 units away, okay, we're talking about the absolute value is equal to 6. So what are these numbers, by the way? Well, you probably drew a number line in your head and you said, okay, well, we start at 7. And we go 6 units this direction, we're going to have 13. And we're going to go 6 units this direction, we're going to have 1. Okay, we'll get to those values. The absolute value function transforms a number into its distance from 0 on the number line. So if I say something like absolute value of x plus 5 is equal to -3, this doesn't make any sense. In general, the absolute value of whatever equaling negative who cares is going to have no real solution, because what I'm saying here, if I think of it like this, a number lives -3 units away from -5. The -5 is fine, but how can I live -3 units away? You can't say, well, it's 3 units to the left, because you just said that's 3 units away. So the notion of -3 as a distance is complete and utter nonsense. The smallest distance that we can travel is 0. And hopefully, while you're watching this video, you're traveling 0 right now. You are not moving from where you are. I hope you're not watching this while driving. I guess while walking is fine. Now, what we're going to do is kind of extend this a little bit. We're going to describe all values within a distance of 4 from the number 5. So pause the video and sketch these numbers out on the number line for me. Okay, so we're saying a distance of 4 from the number 5. So we're going to start with 5. And we want everybody within a distance of 4. So 4 units away from 5, that's going to put me at 9 to the right. And 4 units to the left is going to put me at 1. Now, here's the thing. It's got to be within. So at 1 and 9, I can't actually be on those points, because if I am, I'm exactly 4 units away. So that's going to be a problem. So what I'm going to need to do here is put open circles. And now I'm saying within a distance of 4. So if I start at 5, I can go anywhere to the left. Anywhere in these spaces is legal. I can also go to the right. Anywhere in these spaces are legal. Okay. Now those notches are not drawn to scale for integers on the number line, obviously. So now let's think about what I'm saying with absolute value. I'm saying that my frame of reference where I'm starting is 5, and I'm talking about some number. So I already know I'm going to have x minus 5. What am I trying to write there? I have no idea. So I already know I'm going to have x minus 5. And I'm talking about a distance. So it's going to be an absolute value. Now, it's going to be within a distance of 4. So let's talk about all the things the distance can be. So it can be 3.99. That's fine. It could also be 3.9. It could also be 3. Whoa, I meant to hit eraser. It could also be 3. It could also be 0.3. It can't be 30. That'd be silly. But ultimately, what I'm noticing is 4 is as far away as it can go, and this distance has got to be less than that. And this is an absolute value inequality. What I've done is I've now created a structure for the numbers that live within 4 units of 5 on the number line. Okay, now let's go ahead and solve some absolute value equations. So here's the algorithm that we're going to use for solving these. First, we isolate the absolute value expression. Get absolute value of something equal to just some number. Well, done. The absolute value is already by itself here. It'll make more sense when we see one that's not. Now, we're going to set the interior of the absolute value expression equals to plus or minus the numerical portion of the equation. What am I even talking about here? All right, so here's what I'm saying. This is the interior of the absolute value expression. So what I'm saying is 4x plus 2 is equal to plus or minus the numerical portion. So 4x plus 2 is equal to 15, and 4x plus 2 is equal to negative 15. What I'm really saying is 4x plus 2 lives 15 units away from 0. So here's 0, and 4x plus 2 lives at negative 15 and at 15. So what I've done is I've written 2 equations to model that relationship. Okay, that's just where it comes from. All right, now we're going to solve each of these equations. The good news is we get to kind of solve both of them all at once because they're basically the same. So I get 4x is equal to 13. 4x is equal to negative 17. And again, they're basically the same equations, so I'm just going to keep doing the steps. And honestly, I see folks really using a lot of decimals here. I think you do well to not do that, honestly. And our equation's solved. So if we wanted to write this in a solution set, which is how you'll see some of these written, it would be 13/4, negative 17/4. The typical mathematical convention is to list the smaller one first, in which case negative 17/4 is smaller, but who cares? That's dumb. And so that's what we did here for solving each equation. All right, pause the video and try this one on your own. You're going to notice there's something a little different about this one. Okay, so first, isolate absolute value expression. We need to do that. We actually need to kind of do step 1 first. So it's not just hanging out by itself. Do yourselves a favor. Do not distribute. Don't do that. There's something weird that might happen with distribution that's a big deal, and it's worth not doing. So first, we're going to add 7 to both sides. And then we're going to divide both sides by 5. Again, I know that it seems dumb. We could just distribute the 5, but that's a really bad idea, I promise. You give creative license for something weird to happen, and we know that's not the case. All right, so here's the good news. Absolute value of something, it equals a positive number. That's great. We don't need to worry about no solution case. That's tremendous. Okay, so now we set the interior equal to the plus or the minus. You can even think of it as like branching off. X minus 4 is 9/5. X minus 4 is negative 9/5. Now, I know I'm going to be adding 4 to both sides of this. So here's the way I'm going to go about this. I know when I do that, I'm going to be adding fractions. So why don't I just go ahead and skip the middleman and change this 4. So the 4, I want to rewrite this as something over 5. So what I'll do is rewrite this as 20 over 5. Why did I do that? Well, 4 over 1, I'll do this over here. 4 over 1 is really just 4. I need it to be over 5, so I'm going to multiply the numerator and denominator by 5. So I get 20 over 5. This should be review, but if you have to look at it again, there's nothing wrong with that. I mean, that's not the mountain I'm dying on. All right, so now we're really just subtracting 20/5. So we're just going to go ahead and add 20 over 5 to both sides. Right? And so now I end up with 29/5 and 11/5. So that was me solving the equation. So again, my solution set is going to be 11/5, 29/5. That's a fifth. Okay. Now let's actually analyze some absolute value functions. Let's suppose I asked you to find the horizontal and vertical intercepts of each function. Horizontal intercepts, we could have a few of these. Vertical intercepts, that'd be silly if I had more than one. It's going to fail the vertical line test. But let's do the horizontal intercepts first. That's where y is equal to 0. All right, so for my horizontal intercept, I know that my y value is 0. I need to solve for my x. So I know this is 0. So now what I'm going to do is solve for x. All right, so not a problem. We subtract 4 from both sides. Okay. So now I'll divide both sides by 4. That's fine. Wait a second. I see something problematic here. How on earth can we say that we're looking for the numbers which live -1 units away from 3? How are we going to find that? What's going on here? Stop that. How are we going to go about doing that? We can't. We can't have the absolute value equal to a negative. So what does that mean? Well, what does that means in this case is there's no solutions to this equation. Since there is no place where this happens, there's going to be no horizontal intercepts. How is that possible? Well, let's consider the graph of this thing. If I were going to graph this thing just by using transformational laws, so absolute value function, this should take us back. It's going to look like a V. It's from 1.1. It's our parent function, our toolkit. The 4 means I vertically stretched it. Boom, so there's that. The -3 means I moved it to the right 3 units. So I vertically stretched it by a factor of 4. I moved it to the right 3 units. Again, this is a rough sketch. And now I'm going to move it up 4 units. Well, if I look at this graph, it's kind of silly for me to say where the horizontal intercepts are because there aren't any. So it makes perfect sense All right, so no horizontal intercepts. We don't need to trouble our beautiful heads over such matters. So now we're going to find our vertical intercepts. That's where x equals 0. Well, this we're guaranteed to have. So prepare your spirits for that. Now I just need to find the y values. So f of 0 okay. So I get 4. Well, 0 minus 3 is negative 3. Now, how far away from 0 does negative 3 live? 3 units. So 4 times 3 is 12, plus 4, 16, 16. Okay. Functionally speaking, when there's a negative number inside of the absolute value brackets, that negative number becomes positive, and if it was positive, it stays the same. Okay. All right, now let's talk about absolute value inequalities. It's not going to work terribly different from absolute value equations, and actually solving the equation is a part of this process. So if you haven't taken a look at polynomial and rational inequalities yet, what you're doing in polynomial and rational inequalities is you're using test values to check whether or not something is actually happening based on the zeros. That's exactly what we're going to do here. So the first thing we're going to do, isolate the absolute value expression. Done. Now we're going to solve the equation, ignore the inequality. So observe that I totally don't pay any mind to the inequality. We will get to that. So we're going to use the procedure that we've been using up to this point. By the way, we can have a solution, so that's good news. All right, so we're going to subtract 9 from both sides. All right, divide by 3. Okay, so now we've got our solutions. If you don't mind, I'm going to erase this space for right now, just so that we conserve space. So I've got x equals -5 and x equals negative 5 over 3 and x equals negative 13 over 3. All right, so now here's what we're going to do next. We're going to use test values. So first, let's plot our points. So it doesn't really matter to me, but we'll just put 0 here. So here's negative 13 over 3. Sometimes it helps to write these as a decimal so that you know kind of what's going on. And we've got negative 5 over 3. Again, like it doesn't matter, but the 0 is just there as a frame of reference. Now what I'm going to do, I know that at these particular points, we've got zeros. Now what I'm going to do is check in between these. And what I want, so what I've got here is these spaces, and I know that these are going to be my proverbial zeros. What I'm going to do is check everything to the left, see what's legal, check everything in the middle, see if that's legal, check everything to the right, see if that's legal. So let's go to the left. Well, what's less than negative 13 over 3? Well, definitely negative 13. That's great. Just as a frame of reference, negative 13 over 3, that's like negative 4.333333, right? And negative 5 over 3 is negative 1.6, blah, 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 blah. Right? Again, sometimes it's really nice to have decimals. So here's my representative for to the left. In the middle of this, we'll say, I don't know, negative 4. And to the right, why don't I just make 0? For whatever reason, it's really easy to plug 0 in. And let's see what happens. So let's start with the negative 13. So we're going to plug that in. 3 times negative 13 plus 9 And what I want to do is see if this is actually going to be less than 4. So 3 times negative 13, it's going to be negative 39. So negative 39 plus 9 is going to be negative 30. Is that less than 4? Well, absolute value of negative 30 is going to be 30. Is 30 less than 4? Heavens no. So it's not going to be in here. I don't want anything to do with that space. All right, now we're going to go ahead and check 4, or negative 4, I'm sorry. Let's check negative 4. You may have to do some of this number crunching on your own. That's okay. So I've got 3 times negative 4, that's negative 12, plus 9 is negative 3. Absolute value of negative 3 is 3. Is 3 less than 4? Yes. Great, so that's going to be a winning space. Now, we're going to check 0. Let's see if 0 works. All right, well, 3 times 0 knocks out, so now I'm just left with 9. Absolute value of 9 is less than 4, which tells me that 9 is less than 4. Certainly not. Now, I want to express the solutions, so what I need to do is express this space. Now, see here that this is less than and not or equal to. That's why I'm using open circles here. So if I were going to write this as an interval, I'm saying that if I'm not going to include negative 13 thirds on the left, but I'm also going to not include negative 5 thirds on the right, but I'm including everyone in the middle. This is absolutely my solution. Okay, go ahead and try this one on your own. Pause the video and work on this one first. All right, so first, we isolate the absolute value. Done. Now, we ignore the inequality and we solve the equation. X plus 4, negative 2. If you don't mind, I'm going to leave that to you, and you'll get negative 2 and negative 6. And now we construct our test values. We use our test values. So we've got negative 6, negative 6, and then negative 2. Now, see here, it's greater than or equal to, so I'm going to include those values. I like to use closed circles just to really make sure that I know what I'm doing there. Test values, let's say negative 7, negative 4, and 0. Why not? So let's start with negative 7. Plus 4, is that greater than or equal to 2? Well, let's see, negative 7 plus 4 is 3. Absolute value of 3 is 3. Is 3 greater than or equal to 2? Certainly. Checks. We're good. All right, now let's try negative 4. And let's see what happens here. So we've got negative 4. Negative 4 plus 4 is 0. Is 0 greater than or equal to 2? Heavens no. So that's not going to work. All right, now let's try 0. Maybe that's going to be our winner. Not to say that there's anything we know about winners that has anything to do with whether or not it's a solution. So we get 0 plus 4 is 4. Absolute value of 4 is 4. Is 4 greater than or equal to 2? Yes. We may not be able to agree on much, but we can definitely agree on that. Okay, so now what I'm going to do is state my solution. So everybody to the left of negative 6 and including negative 6. So I'm going from negative infinity up to negative 6. Observe that I'm going to be including negative 6, so I'm going to need a bracket. And then from everybody from -2 to the right, including -2. So I'm going to include -2 and everybody to the right. Put this together with a union. And that's our solution. That's everything for absolute value equations and inequalities. As with all things, you'll need to be just kind of practicing this, but if you notice, test values is really what you're going to, be using a lot for the inequalities. You've already done this with polynomial and rational inequalities. Good luck.